Hi, welcome to Dr. Raz the Baking Chemist. So, did you guess what my Instagram post referred to? All of those activities are increasing disorder, i.e. increasing entropy. And that's what this topic is all about. And well done to those who did guess it right. In nature, every procedure, everything that happens tends towards increasing disorder, i.e. increasing entropy. So let's get on with the topic. So as promised, this week we'll be talking about entropy. It's a continuing question from last week. It's an A-level or year 2 question. Okay, let's see what we can do. Okay, so this was what we did last week. So it was all about Born Haber cycles and enthalpy of formation of barium chloride. And then at the end, as I said last week, the second part of this question is use data from the part A2 and the entropy data given below to calculate the lowest temperature at which the following reaction becomes feasible. Okay, and there's a reaction that they want us to work out. Now, as soon as I see that word feasible, I immediately know, thinking, okay, free energy, delta G. And so the first thing I do is write down the equation. And of course, you should know what the equation is. So delta G equals delta H, let me write a bit bigger, minus T delta S. Okay, this equation is, or should be, your bread and butter, yeah, for for this chapter or this topic, entropy. So delta G is free energy, delta H is enthalpy change, so free energy change, enthalpy change, and T is temperature, and entropy change is delta S. Okay, now as soon as I've done that, I'll go through it at the end, but as soon as I've done that, that's a mark. But anyway, let's continue. So there's a question that I've written. So remember, in my these videos, I'm going to start, I'm going to talk about what I'm thinking as well, yeah? So you know what my thinking processes are. Okay, so what I'm finding is that they've given us, just going to move that. Okay, so they've given us barium chloride, and I might as well write the equation here actually, because I don't want to keep turning it back and forth. So the equation they want us to do is barium chloride solid goes to barium. So it's the opposite of lattice enthalpy. Lattice enthalpy is the formation of barium chloride, but this time it's the dissociation, as lattice dissociation of barium chloride. Okay, so that's the equation they want us to work out. And now I won't have to keep changing it. Okay, I'll keep turning it around. All right, so barium chloride is 124 entropy change joules per Kelvin per mole, and that's important. Remember, this is joules, and I'll say a bit more in a minute. 124, 63, and 223. Okay, so I need feasible, right? Feasibility. You should know that a reaction is feasible when the free energy is 0. Okay, that becomes feasible. Okay, anything less than 0 is feasible, but when does it start to become feasible? It's at delta G 0. And of course, the question is talking about the temperature at which the reaction becomes feasible. In other words, what's the first temperature? And that's 0. Okay, so I know that has to be 0. So okay, let's do something with this equation. I'm just making sure that you can see all of this. Right, so obviously what I need to work out is temperature. Okay, common sense, that's what the question is asking. So what I need is delta H, enthalpy change, and entropy change. Now, enthalpy change, well, enthalpy change of what? Well, enthalpy change of barium chloride. And that's why they need, that's why they said use the data above, because guess what? Enthalpy of formation of barium chloride is that. Enthalpy of formation of barium chloride. Okay, now we've got to be careful because that is the enthalpy of formation, in other words, going this way. Now, because this is the opposite, this is enthalpy of dissociation, so I've got to change the sign here. Okay, so now, so delta H of barium chloride is equal to, might as well write it down, 859, and that is kilojoules per mole. Okay, that's important. Alright, that's important. Alright, as you'll see in a second. So delta H I've got there. Okay, actually while I'm doing this, you need to understand that delta S is joules per Kelvin per mole. Okay, as it says there. Right, joules per Kelvin per mole. Delta H is kilojoules per Kelvin per mole. And in terms of sort of free energy you're talking about, you need to have consistent units. Okay, in fact in any equation you need to have consistent units. Okay, so I need to change that kilojoules to joules. Alright, so how do I do that? Very simple. I'm now going to make that multiplied by 1000, obviously. Okay, so it's 859 times 10 to the 3 standard form. Okay, and that is joules per mole. Okay, so now remember, I need to find T here. Alright, so what I need to do is rearrange this formula to make T the subject of the formula. Okay, very simple. I'm going to move all of that, because it's minus, yeah, I'm going to move all of that around to give me plus. So it would be T delta S equals delta H. Still not finished yet, so what I do is I divide T by all of it, because I need to get, sorry, I divide delta S, yeah, by all of this, both sides. Okay, why? Well, because I need to get rid of delta S here and I need to put it here. So I need to divide it here, and that'll get rid of the delta S, and of course I need to divide it here. So what it'll give me is T delta H over, make sure you're in year 2s now, so make sure you are comfortable with rearranging equations. Okay, so there is my rearranged equation. Okay, and so now what I do is simply I put in that in there. Okay, so enthalpy change in there and entropy change. Now I haven't got entropy change yet, I've not worked it out, so I need to work that out. So okay, I've done delta H, let's work out entropy change. Entropy change, or even entropy change, is equal to sum of the entropy of products minus sum of the entropy of reactants. Okay, and so, oops, sorry, I missed that sum, and you cannot miss the sum. Okay, it's not just entropy of the reactant, it's all the reactants, entropy for all the reactants. Okay, and entropy for all. Okay, so in this case, the way I've written the equation, the products are that, so I'm just going to say 63 plus 223, so 63 plus 223 minus, and the reactants, there's only one reactant, and that's 124, so I might as well just put 124, and that gives me an entropy change of 162. 162 what? Well, entropy change, joules per Kelvin per mole, yeah? Joules per Kelvin per mole. Okay, now if you're not sure about the temperature units, well look, that's giving you a hint, isn't it? Look at that units, they're using Kelvin, so the temperature will be in Kelvin, just saying. Alright, so now I've got delta S, I've got delta H, slot it into the equation, so 859 times 10 to the 3 divided by 162, yeah, and that equals 5302, 5302.47, 5302.47. Running out of space there, so I'm going to rewrite it here. 5302.47 units. What? Remember what I said earlier, yeah? If you don't know, look, those units contain Kelvin, so this must be Kelvin. If you put degrees Celsius, that's a major problem. Right, significant figures, does it say how many figures do we want the answer to? Nope, it doesn't. Okay, so, I mean, as I say in that question, they're giving us up to 4 sig fig. Alright, 3 sig fig, so I can probably put 4 sig fig, so I'm going to just say 5302, yeah, Kelvin. Okay, and that is your answer, 5302 Kelvin. Okay, so where students go wrong, or where the marks are allocated first. So where the marks are allocated is either you're writing the equation. So writing the equation either this way or this way, yeah, or this way, you will get a mark. So that's 1 mark. Working out the delta S, that's 1 mark. Changing the kilojoules per mole to joules per mole, that's another mark. So that's 3 marks. And the final mark is, yeah, for the actual answer, which is a 4th mark. Okay, so where students go wrong is major problem. Yeah, I've seen it so many times. They forget to change that kilojoules to joules. Okay, so that needs to be changed to joules. Okay, major issue. Yeah, I see it so many times. So make sure you're not one of them. Products minus reactants. Okay, so remember, I mean, silly things like not adding these together, making a mathematical error here. Okay, so that's the answer. So that's 4 marks. So that's one of the mistakes. Yeah. So I think the main mistake is over there. Yeah, not changing the kilojoules to joules. Rearranging. If you struggle with the rearranging, I don't think I've seen many students with this kind of mistake where they can't rearrange this simple equation. But you know what? It happens. The one thing I have seen actually is this swapped. Yeah, so they say delta S minus T delta H. Okay, be careful. All right, memorize that equation. No 2 ways about it. It's not a difficult equation. Okay, so it's a quick video today. Just a 4 marker. As I say, I was going to finish that question off. Next entropy question that I do, it will be a bit more sort of in depth, yeah, and a bit more challenging. Okay, try entropy questions. Okay, give me any suggestions down below. Have a look at some of my other videos that I've been putting, for the past few weeks, and give me a like or subscribe. Okay, I'll see you next Tuesday. Bye.